Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So, without any further ado, let's get started. Today we are going to look at another very useful feature of Google Cloud, which is Firestore with vector similarity search. So this way, using the vector search in Firestore, we can power up semantic search functionality and capabilities for our applications. So first, we look into what is vector similarity search. So vector similarity search allows for querying high dimensional data like embeddings for nearest neighbors. So when we say high dimensional data, the vector size is about 768 in dimensions, right? So that's how a high dimensional data we can assess to get the nearest neighbors and queries that fall under this category. These are also used in ML and NLP tasks, example recommendation systems, semantic searching, and image similarity. So we've seen this particular vector search paradigm, which has grown a bit popular these days, from various SaaS providers like DataStrax and Vertex AI, as well as in AWS. But Firestore was the only bit in Google Cloud arsenal which was falling behind with this one. So earlier we could use compound queries and single field queries, but now they have enabled this particular vector search functionality as well. So just to note, Firestore vector search is natively getting support inside Firestore, so no other data pipeline is needed. It is optimized for vector indexes. It supports various distance metrics like dot product, cosine, and Euclidean, as we will see in this video. Lastly, it is available in native mode, so it's not quite available in the data store mode of Firestore DB. Most importantly, this time the vector search that we are going to see has been built with developers in mind and not just data scientists. So the primary goal of this tool is to provide semantic search in apps, personalized recommendations, mostly in e-commerce and similar shop websites, document and image similarity. So if we have a particular multimodal scenario where both document and image deliver meanings to the embeddings, then we can call in vector search in Firestore to do the job. Lastly, chatbot retrieval enhancement has also been integrated. But we'll not go for the chatbot one in this video. Maybe in some later video we'll have that. Today we'll look into the search part, focusing and how we can get semantically similar query results without using any RAG or Vertex AI function upfront. So first we set up the vector search in Firestore. So for that we need Firebase project with Firestore enabled. So that can be done. So all you need to do is basically go to your Firebase console and choose the particular project you are working on, and inside that make sure that Firestore database API is enabled, right? So once this is enabled, now we are good to go. You may also want to add some dummy data here, so in order to test out the search functionality which we are going to build. Now returning, so that was Firebase project with Firestore enabled, and Firestore has to be in native mode. So for checking out the native mode, what we can do is in the Google Cloud console, the database that we are dealing with needs to have Firestore as native enabled, right? So if we create a Firestore database, and in that we are having with Firestore as data store compatibility or the normal one. So keep it the same in order to achieve the vector search functionality in. Then Firebase needs to be in Blaze plan. It is required in vector index usage. So for that, in particular, when you go down here, you'll see a plan to choose. So by default, when you onboard in Firebase, you'll be using the Spark plan. So you need to switch to the Blaze plan in order to get the vector search functionality into it. Lastly, there are multiple SDKs that are available: Node.js, Python, also Go and Java, right? So these all have been given support for So for Node.js, what we require on our dependency level is Google Cloud / Firestore, a dependency of 7.10.0 or above, and for Firebase admin 12.7.0 or above. And just to note that this particular vector search capability has not been implemented in the client side yet, meaning that if you are using Firestore directly from your client side frameworks like React or Vite, then you probably need to have a API end to get the vector search up and running, because it is not directly supported in client side libraries. Okay. Next, we go to the generate embeddings section. So inside generate embeddings, we have first choose an embedding model. So for that, if we click for text embedding API, so we probably need here a text embedding API, right? We want it to generate the embeddings for us based off the data that we give, and we just need the embeddings. So we can use OpenAI, we can use text embeddings from Google Cloud itself. So for this tutorial, I will use the text embeddings API from Google Cloud, but you can test it out with OpenAI as well. So if I click on it, here we have different models that we can use. So for English, when the documents are written in primarily English, we'll have these embedding models. This is the latest one, text embedding 005. So we'll use this. For multilingual models, we have text embedding gecko multilingual 001 and embedding 002. And for Gemini embedding models, we have this one, but this is in a experimental phase, so we'll choose the stable version, text embedding 005. Once we've chosen this, we need to understand that this particular API is just for the text. So if your data is not only text but also images and requires the embeddings to get a sense of both of them, then it makes more sense to use multimodal embeddings instead of text embeddings, right? It's when the document contains some images as well. Although we don't store it efficiently there, we will probably use cloud storage for storing images. But in any case, if you are trying to put images and text together and get an embedding generated out of that, then multimodal embeddings will make more sense. But in today's example, we are looking at documents with primarily textual data in different fields. So we'll use text embedding 005. Next, we come to the task type. So task type has a bit of description to it. We see that there are multiple choices here. So in our case, we have the document stored in Firestore and we want to retrieve it later on. So when we are generating embeddings for the documents, we'll use retrieval document as the task type. And when we are using to embed the query itself, means whatever the user is typing in the search field, then we'll use retrieval query as the task type. So this gives a sense that we'll undergo embedding generation for each query as well as each document when it gets updated or created. There are other as well, be it semantic, similarity, classification. So we'll go through them each one here. As they say, retrieval query specifies the given text in a search or retrieval setting. So based off the query given from the user, it generates a embedding for that. Retrieval document is given to a text document which allows it to get retrieved based off the retrieval query embedding. Semantic similarity is more of used when we are trying to assess the overall meaning of the document stored and not a single document retrieved out of others. Same goes with classification clustering. Question answering is more of when we want to develop a vector search that just answers the question rather than retrieves some documents. So on, right? So you can test out different task types according to your data. But for this example, we'll go with retrieval document and retrieval query. So once that's done, we go for normalization, right? And normalization we'll do inside cloud functions for this operation. So first, let's take a look at the cloud function to generate embeddings for the documents. So let's now go to the cloud function section. So here we'll see that in the requirements.txt, functions framework is the default for every cloud function. Google Cloud Functions is the supporting library for this one, Google Gen AI and NumPy. So now if we look into the code or actual main.py, we'll see that the first one is basically the import, and then we normalize the vector. So for that we first take the embedding, and the embedding array is basically np.array, which converts it to a NumPy array, and then we normalize it, which is the embedding array itself. And if norm is 0, just to avoid division by 0, we return the original list, right? For others, we divide it by the norm and convert everything back to a list format. Now let's see how this normalization is used. So first we take the request and get the request as JSON, and inside that I am taking the field called text and we are converting it into a JSON format. Once that is done, so here when I was testing it, I used the Google API key as well, but when it's enabled across the entire project, we can use genai.client as well. You can specify the model name here, and then the response type or the function calling statement is client.models.embedContent, where you specify the model name, the contents and the embedding configuration. So here we specify retrieval document, the output dimensionality. Now keep it not quite less and not quite large, right? Because we remember that in Firestore there is a limit of 1 MB per document, right? We will have to keep that, as well as if we look into the vector search documentation, we'll find that it has a embedding dimensionality cap as well in the search function. So 768 is good for mostly all the use cases, and we can title this thing to basically segregate out the different embeddings that we are generating. So let's say this is for the venues collection, so document about the venue. So all the documents that are getting embeddings generated will fall under this same embeddings category. So now if we want to generate embeddings for another set of documents, let's say businesses, so there I'll put document about businesses. So later on, even if we merge all these embeddings into a single index, we'll still find relevant data coming across the search. Lastly, we take the embeddings response.0 as the values, right? And then normalize it using the function I just described above, and then we return the embeddings to the calling function inside our backend, which we'll see later on. So that was for the generation of embeddings from the documents, right? Now this is for the query embeddings. So here you can simply copy paste the entire code for the previous one. Only thing that will change is the task type being retrieval query, right? This will change, every other thing will remain the same. Also, we will have to comment out the title, because queries don't need any title and it will simply fail if you try to do so. So that was for generation of embeddings for the queries. So that brings us to the end of generating embeddings for the documents and query. Now let's go to the next part. So now we are going to integrate the functions with the backend. We need to set up the logic to send the data to Cloud Function from our Node.js backend. Then we convert the embeddings that we receive to a vector, which Firestore can understand. Lastly, we store the data with document fields, the other fields, into Firestore. So now let's get to the code. So first up, we'll understand that here, as we can see, that the version is 7.10.0, right? Later on, as Firestore grows with this functionality and adds in more search capabilities, you might need to switch it over to a higher version, right? So that makes sense, as right now you can see that Firestore has the latest version of 7.11 as well, right? So similarly, it will go up. Other one is Firebase admin. So if we click on it, you see the latest version is 13.2.0, but this will also work, okay? So now let's go to the place where we receive and send the data for embedding. So let's go to the create venue part. So here what we are doing is we generate the embeddings for the relevant fields. So Here comes the more tricky part is, let's say your business requires to hide some of the fields while generating embeddings, right? Let's say you don't want the business phone numbers to be shown into the search results or queried for in the search table, right? So there is what we are handling this. So we want the venue name, venue description, venue category and the full address. Only these fields, if the user searches, will be able to match them. So the compliance requirements need to be met here. So whatever data fields are not supposed to get sent across for embedding generation needs to be decided at this point. And if you see, what I am doing is I am filtering out if they are available and joining them via a space, but you can use a different separator or delimiter as per your use case. So here next we use the await keyword to generate the embeddings. Now if I click here, we will go to the particular function, right? Here we accept the text string and then we send it to that particular cloud function, right? You can put additional security here by passing in auth token, but for now I am just keeping it simple for use case purposes, and simply fetch the embeddings that we are getting. You can handle the error here as well, and then you get the embeddings, right? So once we get the embeddings, then we can simply put it in a field called embeddings. Now here is the more important part. What we need to make sure is that we have these things imported from Cloud Firestore, which is field value, vector query and vector query snapshot, right, from Google Cloud Firestore. So now what we need to do is use the field value dot vector method to convert these embeddings, which is, as you can see, an array of numbers, right? We need to convert it into a vector using this particular function. Once that is done, we simply put it in a field called embeddings. Now we need to keep in mind that what is the name of this field in Firestore. Same goes with the update. So if we check on the update piece, you see I am doing the same thing here again. I am passing the venue name, venue description, venue category and joining them via a space. And then the same thing goes, and I use the field value dot vector method to convert it into a vector again. Mind it that if we pass in the direct embedding, search will not work, right? So that's how we'll ensure that vectors are getting generated from this point itself. So that was the part for this one. Now what we need to do is, the next part of this is create index, right? So for creating index, we need a composite index this time, right? If you are familiar with Firestore, you will be knowing that there are single as well as composite index. So we will be using a composite index, and I'll show you how to create that using a gcloud CLI command. So what we will do is go into the activate cloud shell button and activate that. I'll open it up in a new tab. So we'll first get this particular screen. So here we'll first set our project ID. Now once that is set, what we'll do is use this particular command. So I'll explain what this particular command says. So it says gcloud firestore indexes composite create collection group venues. So collection group is something that we'll understand, that if let's suppose the venues is having multiple collection inside it in a document, so then it's kind of a collection group and not a single collection, right? So that's when Firestore needs to know it beforehand, so that later on we don't need to make changes in the indexation part, right? So just to make it future proof, I have kept it like collection group venues. You can do collection also, it will work. Query scope is collection, since we are just concerned with the collection itself, first layer venues, that's why. Then it is field config. Field path is embeddings, which is this particular field, right? So we want to give that. So vector configuration will contain the dimension and the flat field, right? These both things will be there. And then database, which in our case is default, otherwise the name of the database. So you can execute this, it will execute here, and then you will get a particular index ID. So what will happen is, in essence, inside the indexes field you will get this, right, which is the name. So name is generated by default just to keep track of the documents, and embeddings is the one which is we have mentioned, right. So you can see the entries are 30, and this is the index ID that I was talking about. This is the size. So once this all is done, so we are now ready to create the querying logic, or I'll say querying function, in order to test out the search query. So as you can see, like, this is a composite index and not a single field index, right. Now this is done. Now we'll understand how to query the index. We need to create the query function and understand the parameters and execute the queries. So for that, let's go to the code. So this is the one. You see, I am getting the query text from the endpoint, and I am also selecting the collection name. So in that way, we can use different collections and queries combinations with this same function, right. Now once the query text is available, the collection name is available. So now here you can see that I am using another function to generate the embeddings for the query. So if we go above, this is the one which I was talking about. So query embedder is separate, the generate embeddings is separate. This is for documents and this is for the query. So we use it. Next we define the collection name, which is also I am receiving from the front end, and then I am creating this embedding field value, which is a vector. Embeddings by itself was an array of numbers, right, but we want a vector to be submitted here. Lastly, this is the vector query function itself. We specify the vector field, query vector, the limit, the distance measure, distance threshold, and distance result field. So I'll explain all these fields one by one. Vector field is the one which it should be looking for while searching, and also on which indexation has been done, right. So that was one thing. Next, query vector, which is the actual query that we are submitting. Limit 12. So limit means the number of documents that we want the query to return. Next is the distance measure. So distance measure can be either Euclidean, cosine, or dot product. But for dot product, we want the embeddings to be normalized first. So in our case, we can use all three. But if your embeddings are not normalized, then Euclidean or cosine can perform better. Then it is distance threshold, which is kind of a mathematical thing. So in Euclidean, distance threshold marks the maximum distance up till which results are acceptable. In cosine, it's a bit opposite. I'll say when it's closer to 1. So if you put 0.9, so all the documents that give the vector distance between 1 and 0.9 will fall into the results, right. So that's how we define this one. Finally, we get the results using the vector query.get method, and we return the particular documents as it is written here. Now what I'll do, I'll demonstrate this live. Let me quickly pull this up, right. Now I'll open up Postman, post request, host 5000 inside body, right. I have given this particular search query. Now I'll hit send. It processes that, and then we get the particular result. So as we remember that we had given the venue name, the address, the description, as well as the category. So the first result was met at a distance of 0.629, right. If we go below, so that was the first venue. If we look here, the next distance is 0.77. So likewise, it is going up in distance. And if we remember, the threshold was 1. So it will never pass 1 in distance. So if we go just down, you see the vector distance was 0.999, and that's it, right. So that's how we can basically experiment with different variations of limit, distance threshold and other parameters as well. Remember that distance threshold is of higher value than limit. So let's say we put a query where there were documents after 1.5, 12 documents let's say, but we put the distance threshold at 1.51. So only the documents which fall from 1.50 to 1.51 will be shown in the results, right? So that's how it works. So that was the execution of querying which I did live, and basically following these steps you can build your own vector search functions inside Firestore which run natively and perform vector search without using any external AI service as well. So that's been it. If you still have any doubts, then feel free to reach out in the comment section below. If you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving.
Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.